Hey, Dodger.
Hey, Mr. Tyler.
Hey, dear. Just make sure your camera's on and get ready to set up your documents the way I've set on the screen so you can get started on the work today. You got 9 more minutes before we start our norms and get into the problem. Here we got two students coming into the room, Franklin, Gabriel. Okay, they just arrived. Both of you, we have 8 more minutes before we start. You want to set up your screens and make sure your camera stays on the entire time of class.
I'm using my phone right now, so I can't cut on my camera.
Where's your computer at here?
You heard me?
Yeah, I heard you. What's going on with your computer? Why are you on your phone?
I'm not at home right now. I'm at my
Okay.
job.
Okay. Well, you're gonna stay on the line and because it's your attendance now, and I'll try to get the work in before 8. The video should be available. I want to say around 4 p.m. or 4:30.
Okay.
So I don't know if everybody can see. I have the Google Doc started. You should have yours started. The name of the document, the header, and then if you could put in the title. See who figures out what the title is once class starts. Who's coming in the room now? Hello, Joel.
Yo,
So we got about a few more minutes before we start class. You guys just well, until the clock expires, just start setting up your document. We got other people coming in. Again, cameras have to stay on, and you have to be in the camera somewhere because we have to make sure you guys are in class so it doesn't affect your attendance. Taking a look at who's
you
in.
good with my shoulder in it?
You said
Or
what?
I said, are you good with my shoulder in it?
Well, if you must not be feeling good today, but yeah, as long as you're present and you're cooperating, Joel, yeah,
All right,
I
cool.
can see your elbow or something that you did. Yeah, your hand. Okay, as long as you're there, dude. Let's see, Lee is here. All right, so in a couple more minutes, I'm gonna do attendance. We got 5 more minutes before everyone else is considered late. In this 5 minute time, you should be setting up your screens so you can follow along with the work today. Okay, let me run through this attendance real quick. Lisa, no, start from, yeah, Lisa Brown is here. Lee Carter is here. Mr. Champagne is absent. Khalil Connor is absent. Raymond Davis absent. Sharon Franklin is present. Sinkara Laitu absent. Gabriel Mayweather absent. Daje Moore is present. Joel Moreno is present. Lamar Porter is absent. Christian Puentes is absent. Ariana Richardson is absent. Melody Terry is absent. Jamil Tyler is absent. Alexis Valdez is absent. Katavish Wallace is absent. All right. So 3 more minutes, give them time to get in here. And then we're going to start with our norms and go through today's assignment. Okay, looks like Melody Terry's arrived. Okay, everybody, we're going to go through everybody else that I don't see on this list is present. Is marked now absent. And it's 10 minutes after. Might as well get started. So let's do our norms and then do some other housekeeping items, such as the word of the day, the term of the day. We're going to explain that later on. and how you can get credit for that by including it in today's reports. Okay. So you should have had time to set up your documents as the way I've done. One screen is for getting information from Edsby. Another screen is to type and get your document going. So we got a diagram to make for today's assignment to understand electricity, and then we have a problem that we have to do. Now I'm going to do there's two parts of the problem. I'm going to do part A. You're going to be responsible for part B. But part B, Sharon Franklin's left. Part B, you're going to finish it off on your own. But you also have a asynchronous problem, which is a problem you do to get your skills up and practice how these techniques work in terms of electricity, electric fields, or just electric charges. So let's get through with the norms first. And we'll go down a list, and I'm going to call on certain students to recite or read out loud one of the academic or basic norms. We'll start with the basic first. So let me pull up my list. And inside my list, the first person at the bat is the lovely Miss Moore. Can you read number 1, please?
No one has the right to hurt another person.
Thank you. Mr. Gabriel, are you there? Can you read number 2?
Education in the classroom of safety.
Thank you, sir. Number 3, Joel. Uh-oh, Joel, are you there? I have to come back to Mr. Moreno. Okay. Mr. Carter, can you read number 3 for Mr. Moreno? Lee Carter, are you there? There you go.
We will never behave in a way that we discard ourselves, our school, and our family.
Thank you, sir. Lisa, can you read number 4?
At Excel Academy in Southwest, students are
Lady or gentleman?
lady or gentleman.
Thank you, Lisa. Melody, can you read number 5? Miss Terry, are you there?
We take part in Excel Academy in Southwest.
Thank you, Miss Terry. Let's keep going, guys. We got 5 more to go. The academic norms. So let's start at the top. Miss Joel's left. Hopefully he's coming back. Miss Moore, can you read number 1?
We respect the opinions of others.
Thank you. Gabriel, can you read number 2? He combing his hair. Gabriel, can you read number 2? Gabriel, I see you. Can you hear me? Can you read number 2, sir?
We respect the culture of the classroom.
Thank you, sir. Mr. Carter, can you read number 3? Lee Carter, are you there? Let me check his camera. Okay.
Yeah.
Okay. Can you read number 3?
We are attentive and participate.
Thank you, sir. Who we have next? Miss Terry, because Lisa left. I hope she's coming back. Can you read number 4?
We have high expectations of ourselves, our peers, and our teachers.
Awesome, awesome. They're not back. I'm gonna circle back to Miss Moore. Can you read the final? Oh, hold on, wait. There's Lisa. Lisa, you back?
Yeah, my Wi-Fi.
Okay, you
read
better
number
now?
5.
Yeah, number 5.
We are here to focus on preparing ourselves for post-secondary endeavors.
That is awesome. Okay. So a couple of quick things, you all. There's an opportunity to gain 25 extra points for including, like we used to do in our composition notebooks. If you had me in class in the building, you would write those terms with that assignment for the day, and it would give you 25 extra points. Now, here are the 2 words you need to get those points, and hopefully you're listening. So I'm putting in the chat the first term, which is the word of the day throughout the school. Moving forward, all teachers are going to be sharing this word to help you guys build up your vocabulary list for SAT prep or just being in the real world, trying to work at a job. Having a good vocabulary helps. So the first term is known as ambiguous. I'm going to take this from the calendar and I'm going to put this inside of chat. So make sure you copy that definition into your Google Doc somewhere so I can know that you at least reviewed the word of the day. Make sure you take that. Now, I gave you an easy one with the word of the day. The next term that you're going to need to get the full 25 points, and you got to look it up yourself, is, let's see what your word of the day is, or your term The term is for the class. So it's like words we use in class to actually define certain concepts that we're going to discuss. So let's start here. The first one we're doing is power. So let me put that in here, and it's in terms of wattage. So you have to put these two terms in there, and what is the definition of wattage? Now, I can give someone 5 points right here, right now, if they can give me in the chat their best representation of what they think wattage is. Okay, so take a moment and look at that. Let me give y'all a second. So take those words and make sure you put their definitions, ambiguous and wattage, in your document. Okay. So let's carry on. Now we're about to walk into what is known as power, and power is a form of work. So in order to do this, we got to understand some basics we did from the past. So who remembers the calculation for work?
Hey, Tyler.
Yes, sir.
I was trying to unmute my thing, and then my computer kind of slammed, and it restarted. So my bad.
Oh, you're good. You're good, man. You got it going though, right? Oh, dang, Lisa, you quick.
Yeah,
Hey,
it's
Gabriel,
good. It just, I don't know why.
it's okay, man. Just try to catch up and get your screen set up, okay? So, Gabe got the first couple of points because he said wattage is a measure of electrical power expressed in watts, right? So you might want to take his definition because that's a very good definition. And then Lisa gave us our first start in understanding how we're going to get power. So you might want to take those equations and those definitions and put them into your Google Docs, okay? So let me go to do some quick attendance. I see Sinkyra arrive. There she is with a little baby. That's cool. Who else am I looking at? Make sure everybody, I checked off everybody correctly. Franklin's back. Okay, I think we're good now. I think we're good. Everybody's here. Okay, shared at the office. Great. So let's jump into the document. And you should be looking at, you should be inside of ESB. And we're going to go through and you're going to read out loud what's necessary for today's assignment, okay?
Mr. Tyler,
yes.
I'm trying to go to the bathroom.
Okay, just come back there. And then thanks for telling me. Sorry, I had to, what did she say? I had to do something for my mom. Okay, but you're back. That's cool. You're back. You can go and stay gone. So if you want to read what's in the chat for 10 points, it's a demonstration only. And it helps your grades out in the long run. You type me, just M-E in the chat, and depending upon who does it first, we'll be allowed to just read out to the class. So who would like to go first? Remember, it's based upon who types me first, not yell me. Okay, go ahead, Lisa.
Hello, all future electrical engineers. Asynchronous problems need to be completed and ready to present tomorrow in class. Asynchronous problems have to be completed as homework and will be checked tomorrow in class as well.
Thank you, Lisa. All right, so the next part that I need to have read out loud is this, and then we're going to talk about the problem. So this person will get 15 points. It's just a little more to read. So let's put that there, and then there'll be another 15 points out there for someone else for reading a question. So type me, who would like to read this statement in the chat? Okay, I think Gabe is saying he wants to do it. He put E. Okay, there you go. Go ahead, Gabe.
Synchronous problems need to be completed and ready to present tomorrow in class.
Gabe, no, start with please remember.
Oh, hold on.
Scroll down a little bit and go to please remember.
Oh, please remember to get maximum credit. All calculation steps for the final answer to complete. The problems need to be uploaded to ESB via the same format that we have been using since the start of the quarter. This format is shown in the video.
Okay, there was more to it, but that's all you want to read. All right, so typed Google Doc, converted to PDF. I've shown you guys how to do this, and a lot of guys have been doing it. And also stay safe out there in Zen. Zen is a form of peace, making sure you guys are well. So let's talk about the next thing, which is our question here. I'll put this in the chat. Now this right here, you should take a moment to copy it from the chat or from EDSB and put it into your problem. So, or into your Google Doc. So type me if you would like 15 points. I'm sorry, it's actually 20 points. It's a nice little statement. And if you want to do it, you have to type me in the chat. So this is worth 20 points. Who would like to read that question for today? Nobody? All right, then I got to volunteer. Okay, go ahead, Lisa.
Problem 1, to pass a slow-moving truck, a driver has to accelerate his fancy 1.30 times 10 to the third power kilogram car from 13.4 meters per second, 30 point mile per hour, to 17.9 meters per second, 40.0 mile per hour in 3 seconds. What is the minimum power required to do this?
Okay, that's cool. Thank you. Thank you. All right, so let's look at this, right? You should have taken, like I said, this problem that Lisa just read for 20 points, and you should be putting it into the document. But before we do, we forgot to put, we come up one, we forgot to put what our title was. Who can tell me what the title is today for 10 points? You type it in the chat and let me know. It wasn't that messy, Lisa. So what is the title of today's assignment? Oh, Lisa got it anyway. Okay, never mind. So everybody see what she put? It's passing fancy versus passing on a lane in a fancy way. And then the topic or objective is understanding power. Okay, so let me come put this here. Bring it up, and then this problem should be aligned to the left. Go. So now we got to create a diagram of what's going on. All right. So let's do that, and let's do it slowly, and then talk about some things you need. In order for us to create a diagram that helps us explain what's going on or visualize what's happening, we got to go to insert. So you click on insert, image, and we're doing what we did last time where we create, I'm sorry, it's drawing you click on. After you hit insert, you're going to click on a new drawing. And by the way, everybody's drawings that participated, they did pretty good on that. So it helped your points. If you didn't include your drawing with your work, it's usually 15 points knocked off. So those that did it, you saved yourself a lot of points. So let's do our next drawing for today. And that's going to be.
Wait, how you get the drawing again, Mr. Tyler? I supposed to go to format.
No problem. So you click on insert, right?
Mm-hmm.
So do it here, insert, come down to drawing, and then hit the plus with the new by it. Okay.
Okay, I got it.
Cool, cool, cool. So once you do that, now you're ready to start drawing out anything that you want to represent as the problem. So you have a road. I'm going to take a line. And then I'm going to take this same line. Make sure you select arrow when you're ready to grab something. And now it's highlighted in blue. I'm going to hold control and press C for copy. And then hold control and press V. And that puts another line there for me. So this is kind of like my highway, right? And with this highway, we have a certain situation occurring where we have, I think I want to say 3 cars. Well, we have 2 cars, but one is what happened to the car behind the truck, and the other is what happens to the car after the truck. And what am I talking about as far as truck? It's in the problem, a slow-moving truck. So the car that is behind the truck, it wants to pass with a certain speed amount. And we're going to discuss that. So let's draw out 2 shapes. One is going to be, I'm just going to choose the second one. You can choose your own, but this will represent the car. And then I want a bigger one, which will represent, so I'm going to copy this image and make it bigger. And this is going to be bigger by just stretching it out. Now it'll be the truck. Okay. So you can use a star, you can use whatever shape, so it should be creative, or you could use mine. But this is what's happening. We have a car here. So we put car. This is
Wait, how you just do that, Mr. Tyler?
How did I do what?
Them square things.
Oh, so you go to, you see here, shape. You click on shape, and then you got all sorts of things you can use. Okay. So you're just using a shape that represents a car, and you can use something different. So the truck, if that helps you. And then all I did, Dajay, is I clicked on the text box to make the word car, so you know that's
Tyler.
Yes.
I'm doing this off my phone. How do I go to that on my phone?
That's gonna be tough on your phone, but you're in Google Docs.
Yeah, because my Wi-Fi low and slow on the computer, so I'm trying to do it on my phone.
Okay. All right. Well, I hope it works for you. But you go to insert Sankara. So let me come out of this. And anytime y'all done with your drawings, you hit save. But where I went Sankara, and I don't know if you have it on your Google Docs screen, is insert and then drawing new. And it should let you create a drawing. Okay. So let me come back to this. If you're not done editing or creating it, just click on edit here. It allows you to go back into the drawing mode and continue sketching out your drawing. So the next thing is I'm gonna label this truck, right? Because we're trying to represent what's happening. So I'm gonna say truck. And I'm gonna put another car in front of it because this is gonna represent the car in the future, meaning the car is past the truck eventually. So copy this and put that there and bring it over here. And this represents when the car eventually passes the truck. So we have car initially, means when you start it. Bring this out some because it's initially there. Then you have a situation where you have car final, which means it's past the truck. You copy this, grab that. I'm gonna bring this over here because this is the car final. Clean that up. All right. Okay. So now we know what we started with and what is expected in this diagram. And we're gonna put an arrow to show the direction of the traffic. So to do an arrow, you just select the line and come to arrow. Make sure you select that first and you draw the arrow. Okay. And if the arrow doesn't do what you want to, it's angled, you can simply make sure you click on select, which is this arrow key here, and you can drag and move the arrow to make it more accurate for yourself. Okay. So there we go. It's showing that the flow of traffic is going in this direction. And there's two more things we got to do before we jump into the problem. We got to annotate the speeds of these cars. So the initial speed of the car was about, where's the text box at? It's right here. So that is noted at what? We got to look at the problem to figure that out. I'm going to say it's about, I don't know, 13.4. Let me look at the chat. Yeah, 13.4 meters per second, right? But 13.4 m divided by s. And that's the speed of the car here. Then we also have to put the speed of the car after it's to pass the truck. So I'm going to do text box. And this is going to be what? What does it say? It gets to 17, right? So it accelerates to 17.9 meters per second. All right, so that gives the reader of your work an idea of what you have done to represent this problem. So if I hit save, that's all you really need. You have this new diagram in your document. Okay, so you need to have that document, that drawing in there. And next is I'm gonna type up a few notes, but I'm gonna put a timer up to give you time to finish up your drawings. So about 2 minutes. But while you're doing that, if you're caught up with me, you could be typing the next few notes. Come down one. And then the notes you guys need are what power is. Power is equivalent to the work divided by the time. Okay, and then we have another equation that we are already familiar with now is what Lisa gave us. That's work is equal to the force multiplied by the distance. Okay, so these are notes that you're going to need. Center that. These are your notes. Let's not forget that power is measured in watts. We talked about watts a moment ago, or wattage. And work is measured in joules. And that's going to be divided by time, which is usually in seconds. Okay. So make sure you have everything you need there. And how much time you got left, because it's trying to give you a little time to catch up with the drawing. I'm gonna re-talk about the notes, but I'm just putting it out there so you guys will have it.
Mr. Tyler,
I'm
Yes.
back.
computer,
Welcome
like it won't let me finish my drawings.
Why? What do you mean it won't let you finish?
Like
What
it's
is it doing? Okay, so you just usually when you do it, did you save and complete the drawing?
yeah,
So
but I
do
can't.
that.
I can't label it like or do nothing else.
You got to go back into it. You know how?
Yeah.
So you click on it and you hit edit, and it should allow you to go back
No,
into
I don't know how to go back into it.
You said you already know?
No, I don't know.
Right, that's what I'm saying. All right, so let me show you. If you're looking at my screen, I click on my document, you want to make sure you have it just all selected, right?
Mm.
When you do that, Daja, you see this little pencil down here that says edit?
Yeah.
Click on that.
Okay.
It should let you back in, okay?
Yeah.
All right, glad that helped. Who just came in? Rihanna. Okay, so what is his name? I'm sorry, what is your name? Who just came in? Rihanna
Bro,
Mars?
it's me, Christian Fuentes. I'm using my sister's thing.
Oh, okay, Christian, welcome to class. All right, all right.
You loud as hell.
Watch your language, guys. Come on, let's still got class going. We're glad you made it. Let me take care of attendance real quick. Been calling your name for a minute. You finally made it. Okay.
Cut it
All
out.
right. All right, we gotta mute ourselves until we're talking. All right, so let's get back to it. You should have this diagram done, and the next thing we're going to do is pretty much write down, I think, the dimensions for work. And we have work in form of, joules, because that's what we measure work in, and force is measured in terms of newtons. We multiply by distance, which is measured in meters. Okay? So you should have all of these aspects in your Google Doc for the assignment to be done correctly, okay? So far, this is what you should have. If I scroll down past the document, you can see that this diagram represents what's happening in the actual problem, okay? So let's continue on. How do we calculate everything out? Well, next we need to set up our known and unknown values. So what do we know? Let's see, what do we know? Some values we have. Let me move this over. And basically, what do we not know? What is the question asking us? Okay, that is pretty much good. Now let's scroll up to the problem again. So it says to pass a slow moving truck, the driver has to accelerate his fancy, which is a truck, 1.3 times 10 to the third kilogram. And that's the mass, right, of the actual car, because it's a kilogram. So we also have to look at the speed. So we got mass, and we need to figure out how we're going to use this mass, right? There's one more equation we got to include here, and that's kinetic energy. So KE, or delta KE, is change in kinetic energy. So change in kinetic energy would be delta. We can just type insert and go to characters and put delta. And this is the actual mathematical representation for this. Make sure you go to math, because you got to do change in or delta and type delta in the search. It should give you this character here for delta. All right. So far, so good. You'll get this little delta here, and it's going to be KE for kinetic energy is equivalent to, and we've talked about this a few times when we said, what's the kinetic energy 2 weeks ago? It's going to be 1 divided by 2 mass, right, times the velocity, and And the velocity we have here is final, right? So VF, but the F is subscript. So velocity final, subscript that, like that, and then turn it off. Turn it off. And don't forget, this is going to be squared. That's one of our terms because we have a final and an initial. Let's do it. There we go. Oh, that's somebody rocking around. I'm like, what are you doing, Dajay?
Oh, let me put myself on mute.
No, yeah, I should say you might want to mute. You can hear everything in our house. All right. So now you should have it where the power of 2 is raised up and the F is subscript. So it's correct. Now we got to do the same thing for the second part of it, which is it's going to be subtracted by, and it's just, believe it or not, you can copy all of this. It's really similar. They're both kinetic energies. One's final, one's initial. Instead of F right there, you put I for initial. So let me turn it off. I want you to ignore all. Yeah, you can see the I there. So final minus initial, and it's both of the kinetic energies. Again, this equation below is for the change in. I'll put the brackets around it so you know this is for the change in kinetic energy. Okay. Now, what is that all measured in? You know, we had discussed that so you don't get confused. There's different dimensions for everything. For kinetic energy, the first part, delta KE, is going to be measured in joules. It's going to be equal to, you can say 0.5 if you don't want to say a fraction, because that's what 1 divided by 2 is, multiplied by a mass, which is usually in kilograms, multiplied by the velocity in meters. So yeah, meters per second. And that's going to be squared, right? So come here and raise it up to the power of 2. Come over 1, turn it off. There we go. And then what is it? You subtract it and you just put the same thing because this is going to be the initial version or final version. Let's see, C. And that's your final. All right, scroll up. That minus is not there. So that in essence is what you're dealing with. This is all, I want to make sure it's clear, the initial version. And this is your final version over here. So you're aware where you started and where you ended at. All right, looks good to me now. Zoom in a little more so you can see it better. So again, we got joules is delta KE. We have the final value for 0.5, which is half, mass kilograms, meters per second squared. That's the velocity. And then you have the same thing over here, but instead of that, you treat it as initial value. All right, I think you said a lot. Let's get into the problem so we can have, you know, at least leave a little early. So 12:59, we get out of here at exactly, what does it say? 1:20, so we're close. Hopefully I could get this done in 10 minutes and release you guys early so you can get ready for your next period. All right, so, oh, and also the videos will be available if you missed any parts, and all this is due by 8 p.m. tonight, typed up in PDF form, okay? So you convert it from Google Doc to PDF and you submit it to ESB to get credit. All right, so let's start the problem off. What are our known values? Well, we know the mass, right? The mass at least of that truck, I think. Scroll up and see. The mass was given as what? 1.30 times 10 to the third kilogram car, right? So that's the mass we're doing. So it wasn't a truck, it was the car. So I'm gonna take this value and put it here. And instead of looking like that 3 there, it's raised to the power of 3. Let me fix that. And now it looks a lot better. And this is the mass of the car. Type car there, and I'm going to drop that down. Great. What else do we know in this problem? Well, let's take a look. We got a velocity, right? And that velocity would be our initial, because it's the velocity the car started with at this point. So initially, that's going to be your VI, hint, hint, is going to be 13.4 meters per second. So we're going to say VI, initial velocity, I'll make that subscript in a second, is equivalent to, we said 13.4 meters per second. All right. Well, do we have a VF, a final velocity we're looking for with this car? Yes, we do. Remember, it goes to 17.9 meters per second. So we can say VF is equal to, what did it say, 17? 17.9, right?
Yeah.
That's meters per second as well. They're both velocities. So let's clean up these letters. These are supposed to be subscript because there's sub indications of the velocities. So I got that one, and I got that one. So it looks correct. There we go. And let's continue on. What else are we given? Well, let's look here. They say, hey, this all happens in 3 seconds. So we know what our time is in this one, right? And we only need one time. We don't have a change in time. We just got T. So T for time is equivalent to, what did they say, 3 seconds? Let's make sure that's correct. Yeah, it all happened in 3 seconds. Okay, so put that there. Now, what are we looking for in this problem? This problem has 2 components, right? So the first part, no, it only actually has one. It just has 2 calculations to make. Okay, I hope Joel comes back. He came back. He's just having internet issues, I think.
Nah, my sister turned it off.
It's okay, man. You be sounding so frustrated, dude. It's okay, Joel. It's really okay. You're back, though. So I'm just putting all the known values down here on this next page so you can see them together. And this is like our notes section in the diagram we made earlier. All right, let me continue on with this because it's 1:03, and I'm hoping I can get this done in 7 minutes so you guys can have a decent break. So unknown value is power. And we're asking, what is that going to be equal to in terms of watts, right? Or wattage. Well, we got to use the calculations we had earlier. Let's start off with figuring out the kinetic energy so we can walk backwards and find the power. All right, so what does that mean? Because if you find kinetic energy, you found work. Notice that the kinetic energy is in the form of joules. So that what links these 2 equations. And when we do substitution method, you guys are like, well, why are we doing this on Thursday, Mr. Tyler? Because I want you in the habit of realizing that you can take an equation, figure it out, and substitute it back into another equation to get closer to your answer. And then once we get this joules here for work, we got to go back and find power. So let's go through the steps. The first one is kinetic energy, right? Because that gives us our total work. So we know the equation for kinetic energy, we did it here, right? If you don't remember, just go back above in your notes section. So strategy. What is your strategy? Strategy is find the kinetic energy. Real simple. So we use this equation, and the kinetic energy is known by plugging in our values next. So take this and go down 1. And that's kinetic energy. But now we can put the numbers in. So we know the mass, and the mass is going to be this number here. So take this, copy that, and replace the mass in both of the final and initial kinetic energies with that value there. So in parentheses, it's that number. What else? Velocity. No, I got to change the mass here too, right? So let's do that. And it's the same mass that goes there. Okay. Looking great. Now velocity. What is the velocity in this case? Well, we got to look at which one we put in first. So this is F for final velocity. So I'm going to take this 17.9 meters per second squared and plug it here for velocity squared final. Parenthesis, plug that in, and that one's done. And then we have to do velocity initial. That was 13.4. We're going to put that in the VI squared. So we take this, come down to this velocity, and plug that in. Close parentheses, because it's all going to be squared. Okay, so far so good. We got to come down one and shrink out this, make this equation smaller, because there are things that cancel out in this. So I'm going to put this here, but I'm going to start canceling things out. So what cancels out is, if you notice, when you take, what is it, kilogram and meters per second squared, you get a form of joules, right? But that's only after you square terms with this power of 2. So I'm going to just change it to what it is so it looks better for you. We have a lot of time. We got 4 more minutes before I try to get you guys out of here. And I want to get you to the power step where you finish the equation off. I have to finish it off, and the second problem, which is very similar to the problem we just did. But meters per second squared cancels. So we're going to strike out. And meters per second squared cancels here, as well as kilograms, because those two come together and all of them just pop out joules. Now, we're still going to square the numerical factors, but when you square and do the cancellation, you get joules altogether. So strike that out. Strike this out. The reason they strike out is because, like I said, they combine. Okay, that's good. And then what happens is you end up with, I want to turn this off. There we go. And what happens is you end up with joules here. That one, that's the initial. And then on this final version, you get joules as well. Okay. So we copy this line, come down one, and write it simplified. So it goes away. Remember, I told you kilograms are gone, meters per second is gone. I can get rid of that and get rid of this, because the 17.9 still needs to be squared. And the same thing goes for over here, where this goes away and this goes away. Okay, that's going to be all squared. So now it looks better. We have joules and joules, and you make sure you subtract it correctly. And what do we get? Well, we got to use our Google calculator for that part. So let me take this. And how does that look? Well, we can talk to Google, but I'm going to take one of the joules out, leave Carter left. Uh-oh, he comes back. And all of this is going to be just joules to make this easier on us. All right. But instead of the halves, you can use, to go quicker in the calculation, 0.5. That's what a half means. 1 divided by 2, or 50%, right? And then 0.5 here. And the reason I did that is because when I want to put it in a Google, I wanted to actually, you know, not get confused. Is that a fraction? Is this on top of that? Or whatever the case may be. So I'm going to Control C. I'm going to try Symbolab, because, you know, Symbolab is, it can handle different fractions and conversions. If I did it in Google, I'll put equal and try it. So this is what it looks like with Google. Looks like it didn't do it correctly, because that's supposed to be raised to the power of 2, and that one too. So I'm going to come to Symbolab so I don't get it wrong. 1 more minute before I do a check-in with attendance, and then see who gets to leave early. Okay, so if I put that in there, you know, I still got to change it, but now I can just say, hey, that's supposed to be a power of 2, right? At least this one, and just raise it to the power of 2. 2 there. And then, like, hey, that's supposed to be a power of 2 as well. This one here. And just raise that to the power of 2. But now it looks a lot better. Let's calculate it out. We end up getting a grand total for our kinetic energy, which is 9,429.91. So that's 9,421. That's our total joule amount, right? Come down 1. We're just about done. And I'm going to put an equation up here so you can finish off the problem. And don't forget, you have an asynchronous problem as well. So the final answer for, not the final answer, but close to the final answer, because you have to use this to get power, is, let's delete that, it was 9,429 point, let me make sure I got it right, 429.91. 429.91 joules. And this is not the end of the problem, because the last step for you to finish it is to do this. You're going to take what you know about power from above, I know, and that was this here. You're going to plug this into the power equation. This is your new work, okay? So what I'm saying is, you have this you're going to use to find the final answer, which is power. But remember, you could also write it as power, put that back, where the work is pretty much delta KE, change in kinetic energy. Okay. So you can use this to finish it off. You have time in your known values. You have to go through the rest of the steps. All right. So everybody should, be able to calculate power, get the final answer, and then turn around and do problem 2. Where's problem 2 at? Did we put it in there? I don't see it. We didn't. Let me put problem 2 in here so you can see it. And then I can get you guys going. So problem 2 is a picture, and it uses a calculation for work and making sure you find out what the picture's output was in power. So you should, after you finish this problem up, jump into 2 and see what happens. No, this is the wrong person. This is this. That's a physics period. So here we go. So after you find total power, you're going to do this here. The asynchronous problem for at home. Okay. So I don't have anything else for you guys. Let me see who's here. Make sure everybody stayed who should have stayed. Okay, so I got Joel, I got Gabriel, I got Dajay, Lisa, Melody, Franklin is here. All right, so 8 p.m. all this is due. I want you to have time to get ready for your next period, which starts at 1:20. Can you scroll up a bit? Yes. Does this help? Because all I'm saying is you're going to have to, as a final step, take power, make it equal to this number here. Then you know what time is from your known values. And I think that was like 3-something seconds. That was, 3 seconds. And that will give you the last number or last calculation of what power is in terms of watts. So I gotta finish that part off and then go back and do the homework problem. So other than Lisa, anybody else got some more questions, or you need me to talk about something, like as far as grades, attendance? Y'all all should know where that stuff is in ESB, right? And I think I gave y'all the 2 words already. I gave you 2 words a long time ago, though. Maybe I should scroll back up to the top of the chat and put it again. If you have those terms in your report, meaning, what is it? We talked about wattage and ambiguous, right? Those are the 2 terms. And Gabe got the points for it earlier. I'm going to put this in here again, because maybe people might not have seen it. Okay. There we go. So that's what you should have. Like, first off, ambiguous. It's adjective, unclear, vague, or vague in meaning. And wattage, Mr. Gabe gave us a measure of electrical power expressed in watts. If you have those things at the bottom of your report with the asynchronous problem and this problem completely, you get 25 extra points. So just something to think about. It's 1:15. So you guys got any questions before I dismiss you to your next period? Because it starts exactly at 1:20. This is like the only 5 minutes you'll have to yourself. So if you don't have any questions, you're free to go. And see you guys tomorrow, 8 p.m. All right, Miss Brown.
That Jane wastes no time.
I see she left. So did Terry. Oh,
As soon as you said feel free, it was like left the meeting.
They did. Okay, they leaving out. Okay, I was gonna say it's on a little break they got. Sharon, are you there? Sharon Franklin, are you there, dear? All right, I guess she stepped away. All right, let me get this video.
I'm here.
Okay, all right. So check out the video. Get on a computer and try to finish this assignment, please. I don't want you failing. All right.
You don't got no questions or nothing, Sharon? No questions?
Well, yeah, I really do. Every time, only reason, like, I know you see that I don't be turning in stuff, like my homework, but I'm doing my notes. And the only reason is that is because I really don't, like, I don't understand none of this, like, how to do the math. I understand some of it, but, like I get caught at the end, basically.
Yeah, Sharon, I wish I could give you that, dear, but it's not about understanding it. It's about following directions. So you just got to go and look at the videos and do everything I did step by step. So this, you just got to follow the steps, type it up, and submit it. And over time, you understand it if you practice it.
Okay.
All right. So just get to a computer and type up what I typed up, and that's majority of the points right there. Okay.
Thank you.
All right. You take care. See you tomorrow.
You too.